Okay, so for this function, we are going to do y equals, or g of x equals 3x plus 5 over x plus 1. We're going to put it into graphing form. So graphing form, the number on the top, the numerator, is going to go inside. The number on the bottom goes outside. And I'm going to put a little dot here just as a little refresher. X times what gives you 3x? 3. 3 times x is 3x. 3 times 1 is 3. Change the sign, so if it was positive, it's negative, and if it's negative, it's positive. Combine them, so positive 3 and negative 3 cancel. Positive 5 and negative 3 is positive 2. G of x, here's your large number that goes in back. The next two will be your fraction. Large number in back, it is a positive 3. Top of the fraction and bottom of the fraction. Okay, vertical asymptote will come from the denominator. So you can show work if you want. If not, what makes the denominator, you can do this in your head as well, what makes the denominator equal to 0? There's only one number. The answer is, so x equals negative 1. Bless you. All right. Take your highlighter, make the dashed lines, and x equals negative 1. All right, now we're going to do horizontal. Since the degree is equal to the degree on the bottom, they're the exact same, we have two options. One would be to divide. 3 divided by 1 is 3. Or, when it's in graphing form, it's the number that's in back. Either way, you're going to get the same answer. Y equals 3. There is no slant asymptote for this. You'll learn about that on Thursday. It does not apply to this problem. So I'm going to do 2 places to the right. And you can do 2 that are directly, or you can skip one. So I'll give you an example. To the right, I could do 0. And rather than doing 1, I could do 2. So they're just a little bit more spread out. So if I plug in 0, 0 plus 1 is 1. 2 divided by 1 is 2. And 2 plus 3 is 5. Go to 0, 5, and make a dot. And again, you could have plugged in 1. I'm going to try 2, so it gives me an idea of how close this is to the asymptotes. So I'm going to plug in 2. And I'm going to use a calculator this time to do the math. So I'd have 2 divided by, substituting 2 for x, 2 plus 1, get an answer, and add 3 to it, and we come up with 3.6 repeating. So we're going to approximate, go over to 2, up to 3.6 repeating. Use those 2 points to draw part of the graph. Okay, now to the left. The first number to the left would be negative 2. And again, you could do negative 2 and negative 3, or you could try negative 2 and negative 4. If you plug in negative 2, negative 2 and 1 is negative 1. 2 divided by negative 1 is negative 2. And negative 2 and positive 3 is 1. So negative 2 and 1. Now I'm going to plug in negative 4, and I'm going to use the graphing calculator. 2 divided by negative 4 plus 1 plus 3 gives you 2.3 repeating. So 2, 1, 2, 3, 4, up 2.3. Before I draw this, I want to figure out what is going to be the zeros. So I'm going to come over here. What are going to be the zeros or the x-intercepts? Remember, go back to the first form, the rational form. Take the numerator and set it equal to 0. Subtract 5 to the opposite side. I'm going to put it into a decimal. Negative 1.6 repeating. So, and you can put it as a fraction, or I'm okay with you putting it as a decimal. So go over to negative 1.6, approximate. Now to find out the y-intercept, remember when we find the y-intercept, x will always equal 0. I'm going to choose to use this one. When I plug in 0 for x, 0 plus 1 is 1. 2 divided by 1 is 2. 2 plus 3 is 5. So go 0, 5, and we've already graphed the y-intercept. As you go to the right, to positive infinity, it approaches what y value? As you go to the right, which y value does it approach? 3. As you go to the left, what y value does it approach? No, in both ways it's going to approach 3, the same number. Okay, domain and range. So let's do it just as interval notation. So again, your domain goes left to right. So it occurs for all real numbers except one number, and that number is negative 1. So it's going to be negative infinity to negative 1, and negative 1 to positive infinity. The range will be from negative infinity all the way up to 3, not touching, and from 3 to positive infinity. I'm going to put lines through these because at this point you don't have to do those in this class.